Okay. Okay, progress constant dates. Oops. Okay. This was my example of showing we're on Eastern Standard Time here in Toronto. Or here in Toronto and Montreal, we're all on the same time on the clock. But really, Montreal is 73 degrees west. It's 1 degree and 34 minutes away from the time standard of 75 degrees. The time standard is exact time. The exact correct time of 2 a.m. of any exact time of Eastern Standard is exact for 75 degrees, close to Ottawa. But it's Montreal is 6 minutes ahead of that. Toronto's 18 minutes after that. So the actual time between Montreal and Toronto is like 24 minutes. So we have to figure out how to calculate these things. So you have your time on the time standard. If I'm going to do a number of examples, so don't worry. Just trying. You just got to look at this first. It's a different way of thinking. It's easier to do it than me thinking, what am I doing? What am I doing? Just you follow the steps, we'll get it. Wherever you're born, you have a time standard. If it's daylight saving time, you take off the hour and then you get the standard time. Then you see what was the actual local mean time when you were born. So the standard time is a center beam. If you're east of the standard time, you have to add 4 minutes for each degree. Each degree of longitude that you move, the Earth turns, is 4 minutes. It takes 4 minutes for the Earth to turn one degree. So to calculate this, we have to see Montreal. You have to see the longitude. Montreal is 73 west 34. The time standard is 75 degrees. So you subtract them. 75 degrees, take away 73, 34 is 1 degree, 26 minutes. Then you just round it off, 1.5, closer to 1.5. 130 would be the halfway mark. So 1.5 degrees. So 4 degrees for 1 minute, 0.5 is 2 minutes. So it's 6 minutes. Montreal is 6 minutes ahead. Like the sun will always have, if the sun's rising in Ottawa at 50 or at 75 degrees west, the sun is already 6 minutes, up 6 minutes. You know, the time will be, if it's 2 o'clock standard time, Montreal is really 2:06. Everyone in Montreal will be using that 2:06. But in Toronto, if you took 75 degrees, Toronto's 79 west 23. So here you have to subtract it the other way. You subtract the time standard from it, and you see it's 4 degrees and 23 minutes from 79 west 23 minus 75. You get 4 degrees 23 minutes. We're going to do this a number of times. Don't get freaked about it yet. And that becomes 423 is 4.5. For each degree, 4 degrees, 4 minutes. That's 16 minutes. 0.5 is 2. It means 18 minutes of time. Montreal is 18 minutes of time, or Toronto is 18 minutes after the time standard. So if it's 2 o'clock on the time standard, it's 2:06 in Montreal. It's 18 minutes earlier. It's 1:42 in Toronto, the local mean time. So we have to calculate this to see this amount of distance. So it's one thing to calculate it to get the standard time, but from the standard time, then we have to see if that's the standard time, what time is it at Greenwich at that moment? We have to, that's the progress constant, and then we have to convert that day time to a day of the year to get the progress constant date. And I'm jumping into progressions now, into the calculations a little bit, but I have each of your examples here. There's a few tables. These are invaluable tables. This is a table that converts minutes to days. You know, if you're 2 minutes and 2 hours and 6 minutes, 6 minutes difference, 6 minutes would be 1.5 days. So you can take, there's 60 minutes and you take the hours, 1 to 24 hours, and you convert to how many days. 2 hours would be 30 days, 30.4 days. So this is something that lets you calculate, work with the timing and convert it to days, normal time. This other box is sidereal time difference. This was for calculating the ascendant moving along, my more complicated thing. I'm not going to touch on that. We use the computer for that. This is a closer up of the same. And I'll be sending you these forms tonight when I send you the copy of the webinar. So this is another form. This is one that lists the number of the year. So if you're born June 17th, what day number of the year is that? Well, you look down, you see 17 on the left here, you follow it over to June, and you see that's the 167th day of the year, day 167. So this lets us calculate any day of the year and put it over to what number of the year. We need the day number to be able to do these calculations. So this is one of the steps we're going to have to do. And you'll notice between 167, there's also a number saying 532, because when you're adding your calculation dates and stuff, it can end up being more than 360, and then it tells you can go further into that. You could still see it's either 168 or 533. Like it's the same. It's just added 365 days to it. Okay. So this is a closer up look at the days are down the left. January, it says January 1 to 31. But if you look at February, it'll only go to 28. March is to 31. You see, when it has the days going across, but it tells you what day number it is. So if you look at February, starts day 32 or day 397. You'll see March starts at 60. March 1st would be the 60th day of the year, or the 425th day, if it added up to be more than 360. They're all listed in this double format. You'll understand why shortly. So this is doing July to December, days to the year, okay, up to 365. And this is a bigger thing for visual to see the minutes to days. We're going to come back to be referring back to these, which is why I have them like this. Okay, so my chart, first example, 2 a.m. Eastern Standard Time, October 17th, 46 in Montreal. Okay, so we're going to come back to the sheet that we had and we just talked at, but we just did it, so I'm not going to take a long time on it, but you have, I know 2 a.m. Eastern Standard Time is correct for 75 degrees west. That's the standard time. I'm in Montreal, 73:34. I have to subtract the Montreal longitude from the time standard longitude. So 73:34, I have to take away from 75 degrees or 74 degrees, 60 minutes if you want to make it an easier calculation. But then I put it here and you'll see 1 degree, 26 minutes is the answer. That's almost 1 degree, 30 minutes is 1.5. So we just rounded off to 1.5 minutes. So 1.5 degrees, I'm sorry, 1.5 degrees. Each degree is 4 minutes of time. That's written up top here. Each degree is 4 minutes of time, so that's 4 plus 0.52, 6 minutes of time. So I'm 6 minutes off of the time standard because I'm east of the time standard. I would add it to get my local mean time, but since I have the time as 2, I'm trying to get the time to get the interval to GMT. I have to subtract this, and then it ends up being I'm 4 hours from the standard time. It's 5 hours from Greenwich, but from Montreal, it's 4 hours and 54 minutes away from England. Toronto would have been 5:18, but I'm at 4:54. So this was first step in the calculations. Everyone has to do this, we'll do this. The next step is we take this 4:54. Oh yeah, we do have to get our local mean time. So the local mean time was 2:06 and 4:54 to Greenwich Mean Time. So here we have 1946, October 17th, 2:06, and that's my local mean time. The time in England for that, I have to add the 4:54 to this. We end up with 6:54. 6:54. What did it happen? Yeah, I had to subtract. Montreal's behind it, so I had to add the 4:50. This is just the GMT. We'll do this in a second. This just lists the GMT at that time. Okay, so let me back up a second here. 4:54 to GMT. 5:54. So then the 5 hours to GMT, 4:54, 6:54. Okay, something's puzzling me there. Okay, sorry. We get the GMT. mean, we've come so far with computers and doing everything with computers. It's funny to walk back and do the calculations. I have this for midnight or noon ephemeris. If you're using a midnight ephemeris, you put the next GMT is going to be October 18th, midnight, 0 hours, which would be October 17th, 2360, 24 hours, like the end of the day. So I change it to 2360 so I can do subtraction. My GMT is 654. I subtract 654 from that, I get 1706. That's the distance of time from my GMT from the moment I was born till the next GMT, till the next listing in the ephemeris, 17 hours and 6 minutes till the next listing in the ephemeris after I was born. Okay, if I was using a noon ephemeris, I'd be using October 17, 12 noon. I changed to 1160, 11 hours, 60 minutes, same thing as noon. So I could do subtract the 654 of Greenwich Mean Time, and that was 506. So I'm 5 hours and 6 minutes away from the next noon. Okay, this is our first step. How many hours and minutes to the next ephemeris listing, next noon or next midnight? Then this just takes the hours to the next GMT. So this has the date, October 17th, 0 hours. This is the next listing. That's the next listing. So rounded off seconds. Oh, something's wrong with that date. 17 AM. No, that's got it. That's the 18th. It should be the 18th here. I did something wrong with this. 1 second. I was just working on these. It's been a long time. I had to make these graphs up and everything for you, and did mine first. So, anyways, it was the 18th. The next GMT is the 18th. So this date should be the 18th, and I'm 17 hours and 6 minutes away from the 18th. 17 hours here. I look up my table. Here we go, hours. 17 hours, 258.7 days. Oh, there it is there. 17 hours, 258.7 days. 6 minutes. Go back up to the same point, the same table. 6 minutes on the left-hand side is 1.5. 1 minutes today, 6 minutes, 1.5 days. So we come back here, and we add the 1.5 days to 257. So this means total interval is 260.2 days. Okay, total interval from to the next noon. The next listing in days 260. If I'm using the midnight ephemeris, if I was using a noon ephemeris, I'd only be 5 hours and 6 minutes. I'd look up and see 5 hours, 76.1 days, 6 minutes, 1.5 days. So I'm using noon ephemeris would be 77.6 days. So I tended to I always used the noon ephemeris because I would be in the middle of the day and never off the day. But the midnight ephemeris, you could be in the day before, day after, it changes the day, but your calculation would always be plus. It's in one way, calculation is easy, but it's easier, but you could forget which day you're in. So anyway, so I've done them for both here because mostly midnight ephemeris are what are available now. So here we come to the next sheet of calculations. My local mean time, October 17th, 2:06 a.m. local mean time. There's my midnight ephemeris. I look up the day of my birthday. Okay, so we go back up to this table, and we're going to go for October 17th, 290. There we go. So I put that. Oh, we did that one. I take the day of my birthday, 290. The time to the next GMT listing and progressed days, 260.2 days. So I add these together, a day 550.2. Okay, I look up what day of the year this is. We go back up to this table, 550.2. We go back to this day for the year. 552 is, let's see, here we go. 552 is July 6th. So if I'm using a midnight ephemeris,